All right, let's dive right in. We're going to tackle one of the biggest, most fundamental questions. A question you could ever ask.
Why is there something instead of, well, nothing? It sounds super philosophical, right? But the answer, it turns out, might be buried deep inside the totally weird world of physics. Think of this as a cosmic detective story, and it kicks off with a pretty shocking fact. According to our best theories, you shouldn't even exist.
So to crack this case, we've got to go way, way back, like 13.8 billion years back, to the scene of the crime, the Big Bang.
So picture this. The Big Bang forges pure energy into particles, and it should have created equal amounts of two things. On one side, you've got matter. That's the stuff that makes up, stars, planets, you and me. And on the other side, it's perfect twin, but with an opposite charge, antimatter. But, and this is a huge but, when matter and antimatter touch, they instantly, poof, they annihilate each other in a flash of pure energy.
So you see the problem, right? If the universe started with this perfect balance, everything should have just wiped itself out. The result would have been, well, a huge, empty cosmos with nothing but some leftover radiation. The very fact that we are here, thinking about this, is stone-cold proof that something is seriously wrong with that picture.
Okay, so to figure out what went haywire, we need to study the culprit, antimatter. But how in the world do you get your hands on it? Well, you build a factory for it. And for that, we're heading over to CERN in Switzerland, home to a machine that is truly one of a kind.
Meet the Antiproton Decelerator, or AD for short. This amazing facility is literally the only place on the planet where scientists can create and tame antimatter in big enough batches to actually study its secrets.
Now, you've probably heard of particle accelerators, right? Like the famous Large Hadron Collider. Their whole job is speed, smashing particles together at insane energies. The AD, though, it does the exact opposite. You can think of it as the world's most sophisticated set of brakes.
Its entire purpose is to catch these rogue antiprotons that are born traveling at nearly the speed of light and then slam on the brakes, slowing them all the way down to just 10% of that speed. Only then, once they're slowed way down, can scientists actually catch and study them.
But wait a second. How do you actually catch and control something that literally vanishes the instant it touches normal matter? It's an incredibly delicate, super precise 5-step dance.
Okay, so it all happens in 5 key steps. First up, production. They basically fire a beam of protons into a metal block. Wham! That collision creates a whole spray of particles, and in that mess are our precious antiprotons. Step 2 is focusing. They use these powerful magnetic lenses to kind of wrangle those antiprotons and steer them into the AD ring. Then comes the big one, deceleration. Inside that ring, powerful electric fields act like brakes, slowing the particles down more and more with every lap they take. After that, they use special cooling techniques to calm the whole beam down, making it really dense and manageable. And finally, step 5, extraction. These now tamed antiprotons are carefully guided out to the various experiments, ready to be interrogated.
And this is where the real detective work kicks in. All the scientists working at the Adria are hunting for the exact same thing, some tiny little crack in that perfect mirror image. Any small difference, literally any asymmetry between matter and antimatter, could be the clue that finally solves the mystery of why we're here.
So, one of the first, most mind-bending questions they had to tackle was about gravity. We all know how matter works, right? An apple falls down from a tree. But what would an anti-apple do? Would it fall down too, or could it possibly fall up?
Think about that, anti-gravity. That would have been absolutely thrilling. It would have completely upended Einstein's general theory of relativity, which is pretty much the foundation of all modern physics. So after years and years of incredibly painstaking work, the alpha-G experiment at CERN finally trapped enough anti-hydrogen atoms to actually run the test.
And the answer was? It falls down. Yup, no anti-gravity, no breaking Einstein's laws. It turns out antimatter feels the pull of gravity in exactly the same way that normal matter does.
Now, I know, it falls down might sound kind of boring, right? Less spectacular than falling up, for sure. But for physicists, this was a monumental achievement, and honestly, a huge relief. It meant our fundamental understanding of the universe is still on the right track. The physics rulebook didn't get torn up. Well, not yet anyway.
But this just makes the mystery even deeper, doesn't it?
If antimatter behaves just like matter under gravity, and if all the other experiments show its properties are a perfect mirror image, then where on Earth did the imbalance come from? Why didn't everything just disappear?
Well, the leading theory is that the balance, it just wasn't quite perfect. The idea goes like this. For every 1 billion antimatter particles created in the Big Bang, there were 1,000,000,001 matter particles. Just one extra. So after all the pairs annihilated each other, that tiny 1 in a billion leftover scrap of matter, that was enough. It was enough to form all the galaxies, all the stars, all the planets, everything we see today. You could say we are the survivors of a great cosmic war.
Okay, and this is a really important point, so let's be super clear. Antimatter is not the same thing as dark matter. Not even close. They're two totally different cosmic mysteries. Antimatter, as we've been saying, is the mirror image of normal matter. Dark matter, on the other hand, is some completely unknown, invisible stuff that makes up a whopping 85% of all the mass in the universe, and it just doesn't seem to interact with us at all.
So, the hunt for that 1 in a billion difference, it continues. But you might be wondering, why does finding this tiny flaw matter so much? I mean, what's the real endgame here?
Well, for one, finding that answer would be one of the single greatest discoveries in the history of science. It could lead to what physicists call a theory of everything, a single framework that unites all the forces of nature. But even on the way there, the technology they're developing has already sparked incredible new ideas, like for highly targeted cancer therapies. And if we look way, way into the future, mastering antimatter could literally be the key to interstellar travel, the ultimate fuel for exploring the stars.
So for now, the scientists back at the antimatter factory keep on searching. They're all driven by that one single profound question. What tiny fundamental flaw in the laws of physics allowed our entire universe to basically win the cosmic lottery? What hidden imperfection in the fabric of reality allowed matter to survive and allowed for everything and everyone to exist at all?